Dear students, in this biostatistic course, we will try to make our talks in two parts. First part is description and illustration of statistical terms and statistical test and comparison in the classical method, while in the second part of our talks we will try to translate what we are going to say in classical statistics uh, into SPSS program uh, applications. Statistic is the discipline that concern with the collection, organization, analysis, interpretation, and representation of data related to certain problem or phenomena. Statistics is divided into two branches, descriptive and inferential. Now, data are collecting on specific characteristics of each subject and the group are formed to be compared. These characteristics are called variables because they can change from each subject. A variable is obtained because it is a result of interest dependent variable, or it explained the dependent variable risk factor independent variable, which means that the collected data is either called dependent data or dependent variable data or independent variable data. Data are classified according to its measurement scales into qualitative, which is either binary, dichotomous, ordinal, or nominal; quantitative, discrete, or continuous. Qualitative data, or also called categorical data, are either dichotomous, like in gender, male or female, or employment status, employment or without employment, or it is ordinal data, like socioeconomic level, high, medium, and low, or nominal, like in residency place, center, north, south, east, or west, while civil status is either single, married, widowed, divorced, or free union. Quantitative data is either discrete, like number of offsprings or number of teeth in the mouth of the patient or number of students in the classroom, while continuous, like glucose in blood level or weight of patient in kilogram or age of person in years. Data summary. Generally, we want to show the data in summary form. Number of items that an event occur is of our interest. It shows as the variable distribution. We can generate a frequency list, quantitative or qualitative. Summary of categorical data. Like list of parasites detected show us an idea of the frequency of each parasite, but that is not clear. If we order them in the idea is more clear. Like here, we ordered the parasite by their names. But if we put them in names and frequency of each parasite, it will be more clear. And if we put the parasite, its number, and its percent, will be better representation. Sometimes we got data must be grouped, like we have to group age of patients into from less than 1 year to 1 year. We put a number or frequency of this age group and its percent. Then the second age group is 4 to 6 year. We put its frequency and percent, and then each age group till 13 to 15 year, and we put its uh, frequency and percentage. Now, to make a group for the collected data, we have to obtain minimum and maximum values and decide the number of intervals. Like in this condition, the minimum value is less than 1 year and the maximum is 15 year, and we divide the groups into intervals, and each interval gets width and minimum and maximum value. Number of intervals must be between 5 and 15. We have to assure interval limits. We have to assure that the width of interval is the same. The width of interval is the same. And we have to avoid the first or last interval being opened. We have to uh, make it clear that the last point is 15 and the first point will be 0. Now we have to speak about the graphical presentation of data. Of course, in categorical data, we can present these data as bar chart or pie chart, while quantitative data, we can present it in a histogram or polygon frequencies. Bar chart, the frequency or relative frequency of categorical variable can be shown easily in the bar chart. It is used with categorical or numerical discrete data. Each bar represents one category and its high is the frequency or relative frequency. Bar should be separated. It is very important that y-axis begin with 0. Now, this is the type of parasite which was mentioned before. Now each type of parasite was mentioned separately, and we put a bar, another bar, another bar according to the frequency that occur or find in each parasite, and it must be separated from each other. Bar chart is either simple, like in this case, or grouped, if like here, male and female was put here in what is called clustered bar chart. Pie chart is an alternative to show categorical variable. Each slice of pie corresponds at frequency or relative frequency of categories of variable. It only shows one variable in each pie chart. If we want to make a comparison, we need to build 2 or more pie charts. Here we got pie chart representing civil status of women in a community. Of course, this is in an American society. Distribution of frequency chart histogram. It is useful to quantitative variable. There are no spaces between bars. The area bar, note its height, represent its frequency. X-axis should be continuous. Y-axis should begin in zero. Width represent the interval for each group. Here we got number of sons in women from Silaya, which is a city. We got uh, these numbers and its frequencies, and we can see that there is no space between bars. Now, if we make a line passed through the center of each bar in the histogram, the result will be frequency polygon. Thank you very much.